In the second part of 1.6, we're going to specifically look at absolute value inequalities and two different graphs that you're going to see when you go through these. So to kind of recap from yesterday, when you graph an absolute value equation, in other words, an absolute value of x is equal to a, when you found your solutions, you just graph the points and you were good to go. When we look at inequalities, two different things are going to happen. In the first situation, if your absolute value of x is less than or equal to a, as you would say it, the distance from x to 0 is less than 8 units away. After you plot your points, you're going to want to shade everything between it. Why? Because you want all the values less than the value of a, which is going to be everything in between them or in the middle. On the other hand, if you have a situation where you have the absolute value of x is greater than or equal to a, after you plot your points, you'd want to graph everything beyond it, because these would all include values greater than the value of a. First, we'll look at a situation where the absolute value is less than a number. So in this situation, we're looking at the absolute value of 2x minus 1 is less than 5, and eventually we're going to want to graph it. So what you're going to want to ask yourself here is this an and or an or problem, tying it back to section 1.5? Here we want values that are less than 5, but also greater than negative 5. So this would be an and problem. How we'd want to do it, or set this up, is we'll make a compound inequality. We want all values of x between the value of negative 5 and positive 5. So from here, to get my solutions, I want to solve for x, which I can do in 2 steps. And I want to divide by 2 to everything. I'll be left with, to make this work, any value between negative 2 and positive 3, if I plug it in, will give me an absolute value of less than 5. So now how I want to graph this is I'll put a dot at negative 2, I'll make it hollow because I'm dealing with less than and greater than, and at positive 3. And I want to shade everything between it. So now, to check to see if that works, let's try 1, for example. And I'll plug that in. The absolute value of 1 is in fact less than 5, so I would be good to go. On the other hand, let's say I wanted to check something like 5 to see if that would work. I see that's going to give me 9. Does the absolute value of 9 give me a value less than 5? No, that wouldn't work. So as you can see, any value between negative 2 and positive 3 is going to work, which is why that graph looks the way that it does. Next, we're going to look at when the absolute value is greater than a number. So here we have the absolute value of 2x plus 4 is greater than or equal to 6, and we'll want to graph that. So while the last problem that we looked at could be considered an and inequality, this would be considered an or inequality. We want a value of x that is greater than positive 6 or less than negative 6. There's not really going to be any overlap here. So how we're going to want to set these up is make 2 separate inequalities. I have 2x plus 4 is greater than or equal to 6, or 2x plus 4 is less than or equal to negative 6. I'll solve them both separately. So if x is greater than or equal to 1, and x is less than or equal to negative 5. So how I'll graph these, I'll plot negative 5 I'll want to circle that in because it's a less than or equal to. Same goes with the positive 1. And from here, I'll want to graph anything greater than positive 1 and anything less than negative 5. Now again, to check to see if this is good to go, let me check something way out to the left like negative 10. I'll plug it in here for x. And from here, even though this is negative 16, remember it's the absolute value. So the absolute value of negative 16 is positive 16, which is in fact greater than 6, and I'd be good to go here. So even though this value of 10 is negative, as I go further and further out to the left and get bigger negative numbers, when I plug that in, the absolute value is then going to be positive. So the further I go to the left, or the further I go to the right, or the bigger values that I have, I'm going to continually have numbers that are greater than positive 6.